Hello, this is Dr. Eddie Morgan over at Clovis East High School, here to help you with your homework. Tonight we're going to be looking at Math 1, Worksheet 3.1. Remember, each of the problems on the homework help mirrors a problem on the homework. So if you're having a problem with a particular one, for example, if you're having a problem with problem 5, fast forward this video to problem 5, and you'll find a similar enough problem that should help you do your homework. Let's get started. Problem 1 says use the following chart to answer the questions. You see we have a chart here. A hockey team's offense showed us a number of games and how many goals they have. And they want to know what is the average rate. So the average rate of change of goals between games. A rate, you remember, is a ratio. And so what we're comparing in a ratio, the ratio is going to be goals to games. Okay. And in this case, they want to say, what is the change? What is the average rate of change between 1 and 2? So we're looking at one game, 2 games. And so what we're comparing is how much does this change? So I'm looking at the change in goals, which is typically you're thinking X and Y, over the change in games. So between 1 and 2, from here to here, notice I have 2 minus 1. And from here to here, the change is it went from 5 minus 2. So in other words, my change is 3 over 1, or the change is 3 goals per game. That's my average rate of change, 3 goals per game. Now, in the next time they ask you instead, they say, okay, so what is it between game 1 and game 3? Well, now we're looking from, let me change ink to make this clear. Now we're going from game 1 to game 3, and there's our change there. So once again, if I'm looking at the change here, the change in Y is it goes from 2 to 8, so it's 8 minus 2, and here from 3 to 1, so it's 3 minus 1. So the change is 6 over 3, and in this case, over that range, the change is 2. 2 goals per game. And so the rate is difference between games 1 and 2 and games 1 and 3. All right, so the rate of change, again, the rate of change is you're comparing how much does Y change, how much does Y change as X changes. That's what you're looking at. What's the change between those two? In problem 2, we're looking at miles per gallon, and we're asking what's the average rate again of change in miles between 1 gallon and 3 gallon. So we want to know, as we use gallons, how much does the miles change? Again, think of the gallons as being the X and this being the Y, and what we're trying to find is the change in Y. This delta, this is a Greek letter delta, means the change in Y compared to the change in X. And so as we look in the first one between 1 gallon and 3 gallons, well, we're going from 1 to 3. So notice how much does that change? If I'm looking like we did before, it's plus 2, or I can do it this way. 3 minus 1 equals 2. And then the change in Y here is 78 minus 24. So 8 minus 4 is 4, and 7 minus that is 52. And so if we simplify that, that is going to be 27. The change is 27 miles per gallon. That's the average rate of change between 1 gallon and 3 gallons. All right. Now in the next one, we want to do it between 3 gallons and 7 gallons. I'll change my ink to see that. So between 3 and 7, that's how much X changes. Notice that's up 4. And this one we'll figure out. So my delta Y, my change in Y over my change in X. For my change in X, we see it's 7 minus 3, which is going to be 4. And for my Y, it's going to be 186 minus 78. So if I'm doing the math right there, let me do it quickly up here. 186 minus 78. Borrow 1 there, and I have 16 minus 8 is 8. 11 minus 7 is 4. So I have 48 divided by 4. And that's going to be 12 miles per gallon is the rate of change between 3 and 7. If you're thinking, what does that mean? Well, it means when they were driving at first, they were probably driving slower when they used the first 3 gallons, so they got better gas mileage here. But maybe the next set, they were out on the freeway driving faster, and so they used more gas. They got fewer miles per gallon doing that. All right? Problem 3 is like problem 1 and 2. This time, we're comparing hours to cars. So we're seeing how many cars per hour between different hours are. So the first one, we want the average rate of change between hour 1 and 2. So between 1 and 2, notice that goes up +1, and this goes up +5. Or if I want to write it this way, the change in cars compared to the change in hours, the change in cars is 10 minus 5, and the change in hours is 2 minus 1. So we end up with 5 over 1, or it's 5 cars per hour. That's the rate at which they're working between 1 and 2 hours. They're doing 5 cars per hour. On the second one, let's look at hour 1 and 4. Now here, I'm going from 1 down to 4. You notice that goes up +3, whereas here from 1 to 4 goes up +15. So again, my change in cars compared to my change in hours. My change in cars, 20 minus 5, and my change in hours, 4 minus 1, so I get 15 over 3, which is 5 cars per hour. In this case, the fact that they're the same means a couple things to us. From last unit, it means it's a linear relationship. It also means that they're basically working at the same rate. They're washing the same number of cars in 4 hours as they were washing when they started in the first couple of hours. So they're being very consistent. Problem 4 asks us to find the slope of each line. Now notice here, the way the slope is our rate of change, but on a graph we use a different terminology. We call it the rise over the run, which is, again, the change in y over the change in x. You have to remember that this is x and this is y. So notice that the change in x is going this direction. That's my run. And my change in y is going this way, up and down. I sometimes figure my little runner out in the morning running, and he runs when the sun comes up in the sky. So the sun rises and the runner runs, but it's the sun is always above the runner, so we have the rise over the run. Now when I have a graph, what I need to do is find 2 points where it crosses the line, okay? So I'm looking here and I realize, kind of hard to see, I got a point here, and again, these can be kind of tough to see sometimes, and I got a point right here. So what I'm going to do is make what I call my little slope triangle. I'm going to go from here and make a little right triangle up here and over here. And now this is my rise up and down, so I count 1, 2, 3. So my rise is +3, and it only goes over 1, so +1. So my rise over my run is +3 over +1, so my slope is 3. All right, find the slope of this one. Again, the slope is the rate of change. It's the change in y over the change in x. Remembering that this is x and this is y. How much does it change this direction? How much does it change this direction? And we often call that the rise over the run, because y goes up and down and run goes to the side there. Okay? So what I have to do here is I'm going to find 2 points where it crosses the graph. And I'm looking for where it crosses. I'm looking for where it crosses right in the middle of those crosshairs. And I'm finding here and here. And I'm going to draw my little right triangle here. And first of all, the rise is up and down. And I notice it goes up 1, 2, 3, 4. Notice that I count the boxes. I'm not counting the lines. And so the rise is +4. So over here, my rise is +4. My run is 2. Okay? So it's +2. So my slope is 2. Now, by the way, notice something interesting. I could have picked this point and this point. And notice if I did that, what I would have gotten for my slope is plus 2 over plus 1, but it would have been the same answer, 2. You can pick any point you want along this line. Okay? So, for example, if I pick, let me pick another point. If I pick this point and made a great big triangle here, notice I have 1, 2, 3, 4, 5, 6, 7, 8. I have plus 8, and I have 1, 2, 3, 4 over plus 4. I still get 2. When you have a straight line, the slope will be the same no matter what 2 points you pick. Again, for number 6, we're finding the slope. And again, slope is the change in y. Y is my up and down part. How much does it change going up or down? Over the change of x. And this is x going this direction. We sometimes call that the rise, because y goes up and down, over the run, and run is horizontal. So again, we're going to find 2 points on the line where they cross the crosshairs. And I'm noticing one here and one here. Remember, I could pick any points I wanted. I could go down here and pick this point if I wanted to. But I'm going to draw my little triangle. Right triangle. And notice there's 2 here, but notice it's going down. So I call that negative 2. So that's negative 2. And then 1, 2, 3. Negative 2 over 3. So my answer is negative 2 over 3. As a habit, mathematicians, we don't usually, when we go to write the answer, we'll put the negative in front there. Okay? So the slope is negative 2/3. Notice a negative slope has a line going down from left to right. By the way, some people would say, well, what if I wrote it over here? What if I made my triangle over here? Well, you can do that. Just remember 1, 2, 3. That's the same there, and down 2 over there, okay? So you can make your triangle either side. Just make sure that it's always the rise, the y portion, up and down on top of the run. Now for number 7, again, find the slope. I'm going to find 2 points. I'm going to pick, you notice it goes the horizontal line, and I can pick this point. I can pick any point. I'm just going to pick a big point here, okay? So notice when I go to draw a triangle, I can't draw a triangle because it's right on the line. But I can do something. Remember, the slope is the change in y over the change in x, or the rise over run. Now, in our case here, I picked here in my run 1, 2, 3, 4. This is going to be over 4. But notice my up and down component. It never goes up or down. So my rise is 0. And so the slope of a horizontal line is 0. So just keep this in mind. The slope of a horizontal line is 0. Okay? Because it never goes up or down. And that'll be true for every horizontal line you find. Now we saw in the previous problem, number 7, that the slope of a horizontal line was 0. Well, what's going to be the case with a vertical line like we have in problem 8? Well, let's set it up again. Slope, remember, is the change in y over the change in x, or we can say the rise over the run. And so let's mark it down here. Let's just pick 2 points. I'm going to pick right here, this point, and I'll go up and pick this point. I can pick any of those points. Well, notice, first of all, I have a rise this time. 1, 2, 3, 4, 5. So I have 5 divided by. Now this time, notice for my x, this direction, it doesn't go anyplace. So like before, since it doesn't go left to right, it's 0. But what's 5 divided by 0? This is undefined. Remember, the only person who can divide by 0 is Chuck Norris. So if you're not Chuck Norris, the answer is undefined. So we can say that the slope of a vertical line is always undefined because we cannot divide by 0. All right, number 9 is a repeat of number 7. If you go back to number 7, we said that horizontal lines always have a slope of 0. But let's make sure, if you forget that, let's just remember what slope is. It's the change in y. In other words, it's the up and down change over the change in x, which is the right and left change. Sometimes called the rise over the run. The rise going up and down and the run going horizontal. Now notice if I pick 2 points, I'm going to pick this point here and this point here. I can pick any 2 points. Notice that my rise, it doesn't go up or down, so my rise is 0. But my run here is 1, 2, 3, 4, and that's 4. So once again, the slope of a horizontal line is 0, always 0. For number 10, it asks us to find the slope of the line that passes through each pair of points. Here we're going to use a very simple formula that we could put on a graph. It says that if I have 2 points, and I'm going to say the first point is x1, y1. Notice those aren't exponents because they're below it. And this is x2, y2. This just means this is the x point in the first, this is the x value in the first point, the y value in the first point, and the second point. We can write the slope this way as y2 minus y1 over x2 minus x1. Okay? Now another way to see that, if I expand this way, if I have 3 and 1 and 0 and 0, this is my second point. So when I go to write this, I'm going to take this one, 0, and subtract this one. So I have 0 subtract 1, and then I have 0 subtract 3. So 0 minus 1 is negative 1. 0 minus 3 is negative 3. A negative divided by a negative is positive. So my answer is the slope is 1/3. Now if we move over to the next one again, notice that I can once again do this. I could say, okay, my slope here is going to be y2 minus y1. So going from left to right, 3 minus 5. And then on my x's, just got to make sure your x's are your run, so they're below 7 minus 4. So that's going to be 3 minus 5 is negative 2, and 7 minus 4 is 3, so my answer is negative 2/3. Now somebody says, well, what if I went the other direction? Okay, what if instead of going from 3 to 5, what if I went the other way? Well, let's just try that for a second. I'm going to go over here and put red for this one. Suppose instead of going from 3 minus 5, I went 5 minus 3. All right, so if I'm going to go this way for that, I just got to make sure I go it for this way too. So I make that 4 minus 7. Notice here I get positive 2 instead of negative 2. But on the other side, I get negative 3 instead of that. And I end up with the same answer. Okay? So whichever way you subtract is fine as long as you do them both the same way. If you went this way for y and that way for x, then you would get the opposite answer. Your answer would be positive 2/3 instead of negative 2/3. So just watch that. Just be consistent. Whatever way you subtract the y's, that's the way you subtract the x's as well. All right, let's continue finding the slope. Let's remember what the slope formula is. The slope formula for 2 points is I find the y in the second point minus the y in the first point, and I divide that by the x in the second point minus the x in the first point. Remember that this is x1, y1, and this is x2, y2. So if I wrote this out here again to see what we're doing, here's my first point, here's my second point, and y2 minus y1 is going to be 4 minus 8. And then the x is going to be 8 minus 3. So I end up with 4 minus 8 is negative 4, and 8 minus 3 is 5. So my final answer is negative 4/5 is my slope. For the next problem here, again, y2 minus y1, so I have 3 minus 0. 3 minus 0 is my y, and my x is going to be minus 6 minus 1. So this is 3 over negative 7. So the answer is m equals negative 3/7. So for every 7 this way, it goes up, it goes down 3. That's what that means. Here it means for every 5 this way, it goes down 4. That's what your slope is meaning, going over 7 and going down 3. And in our last two problems, let me state again, the slope formula says that the y in the second point minus the y in the first one, that's my change in y. Remember how we talked about this was the change in y? That's what that means. I'm subtracting the y's. Divided by the change in x, that's going to be the x in the second one minus the x in the first one. And so when I go up here and I'm looking at this, y2, the y in the second one, subtracting the y in the first one. Watch your signs here. This is minus 4 subtract minus 5. Notice I'm subtracting minus 5. Do not get confused here and think that this is somehow, sometimes people see the minus 5 and they'll lose one of those. I am subtracting negative 5. Okay? And on the other side, I have minus 6 minus 7. Minus 6 minus 7. Now this right here is the number one mistake that's going to be made by some students doing slope. They forget that when you subtract a negative, subtraction is the same as adding the opposite. So I can rewrite this as minus 4 plus, and what's the opposite of minus 5? Plus 5. And so I end up with this as my answer. And notice some of you may have had elementary school teachers that taught you to do this, and it works. They may just not have been able to explain why they did it. Whenever you see minus minus, just make them both positive, and you'll be in good shape there. So now, coming back to our problem, minus 4 plus 5. So, or turn it around, 5 minus 4 is 1. Minus 6 minus 7 is negative 13. So my slope here is minus 113. For the next problem, again, our slope is our y2 minus y1. Notice we have, once again, 5 minus 4. And then here we have 6 minus 3. So again, subtracting a negative is the same as adding the positive. So I can change that to 5 plus 4 over 6 plus 3, and I get 9 over 9, or my slope equals 1. All right, that's the end of our homework help. I hope it helps. We'll see you later in class.